In this problem, we're using the work kinetic energy theorem to solve a problem. The problem reads: a 2,000 kilogram car starts from rest at the end of a driveway 5 meters long, with an average friction force of 4,000 newtons impedes the motion, and there is a 7,500 Newton forward force acting on the car. What is the speed of the car at the bottom of the driveway? So here's our driveway. We'll draw our situation. And so there's a forward force, it says, of 7,500 newtons and a backwards frictional force of 4,000 newtons acting on the car. We'll write down our givens. The mass of the car is 2,000 kilograms. We also have that it starts from rest. And we have that the driveway is 5 meters long. Now, I have a few different ways of labeling this 5 meters, but when we're discussing work, it uses a letter D for the distance, so we'll use the letter D. This frictional force is 4,000 newtons, and we have the applied force, the forward force, I'll call it the applied force, of 7,000 newtons. And we want to find out what is the final speed of that car. So we go to our work kinetic energy theorem, and the work kinetic energy theorem says that the total work is equal to the change in kinetic energy. What I'd like to do is I'd like to expand upon this a little bit and write it out. The net work is force times distance times the cosine of the angle. And if it's the net work, that means it is the net force, meaning the total force acting on the car. The change in kinetic energy, well, kinetic energy is 1/2 mv squared. And if it's the change, it means to subtract the initial and the final. And it's always the final minus the initial. And that's important. It's always the final minus the initial. So to solve for the final speed, that's this right here that we're looking for, we need to know the initial speed, which we do, it's 0, the mass, which is 2,000, the distance, which is 5 meters. We need to know the net force. That's the total force. Well, we have two forces here. We have an applied force, which is forward, and the friction, which is backwards. So to get the total of those two, the net means the total. I'll write this over on a separate page. To get the total, we have 7,500, which is forward, and we have 4,000, which is backwards, so that's negative. And so when we add the two, we get 3,500 newtons, and it is forward. Now the last thing we need is this angle. The direction of the displacement, the direction of the motion, is forward. And the net force is also forward at 3,500 newtons. And so since they're in the same direction, the angle is 0 degrees. So if it is, I'm going to just write here, it moves in the same direction as the motion, as the force, I'm sorry. So the angle is 0 degrees. And so when we put in our values, we have the net force, which is 3,500 newtons. We have our distance, which is 5 meters. We have our angle, which is 0 degrees. Then we have 1/2 the mass, which is a 2,000 kilograms, times our final speed squared, which is what we're looking for, minus, now I'm running out of room. So we have 1/2 times 2,000 times 0 squared, which is 0. So because the initial speed is 0, we know that 1/2 m times 0 squared is also 0. I just did that because I'm running out of room. Now we solve for our answer, And we get the final speed comes out to be 4.18 meters per second.